Objective 4. Determine and interpret the interquartile range. So far, we have discussed three measures of dispersion: range, standard deviation, and variance. None of these measures of dispersion are resistant. Quartiles, however, are resistant. For this reason, quartiles are used to define a resistant measure of dispersion. The interquartile range, also abbreviated as IQR, is the range of the middle 50% of the observations in a data set. That is, the IQR is the difference between the first and third quartiles and is found by using this formula. IQR is going to equal quartile 3 minus quartile 1. Now, the interpretation of the interquartile range is the range of the middle 50% of the data. The more spread a set of data has, the higher the interquartile range will be. The interquartile range, IQR, is a resistant measure of dispersion. For example, finding and interpreting the interquartile range. Determine and interpret the interquartile range of the collision claim data from the table in the previous example. So here is our table. Okay, using the quartiles found in the previous example, we want to find the interquartile range, IQR, by computing the difference between the first and third quartiles. Okay, now it represents the range of the middle 50% of the observations. So let's go back and let's discuss here. So back in our previous example, we found that quartile 3 was $4,668. And then we found that quartile 1 was $735. So what we're going to do is we're going to be able to then take quartile 3, which is 4,668, and then we're going to subtract quartile 1, which is 735, to get the result of 3,933. So the IQR, or range of the middle 50% of the observations for the collision claim data, is 3,933. The IQR is used as the measure of dispersion for data sets that are skewed or contain extreme observations because it is a resistant measure of dispersion. Now, deciding which measure of central tendency and dispersion to report. Okay, so let's compare the measures of central tendency and dispersion discussed for the collision claim data. Now, the median we found was 1,805 is a more representative measure of center than the mean because the data are skewed to the right. Only 5 of the 18 observations are greater than the mean, which is 3,874.4. Now, the range is 21,147 minus 180 is 20,967. The standard deviation is 5,301.6, and the interquartile range is 3,933. The values of the range and standard deviation are affected by the extreme claim of $21,147. In fact, if this claim were $120,000, let's say the claim was for a totaled Mercedes S-Class AMG, then the range and standard deviation would increase to 119,820 and 27,782.50 respectively. The interquartile range would not be affected. Therefore, when the distribution of data is highly skewed or contains extreme observations, it is best to use the median as the measure of central tendency and the interquartile range as the measure of dispersion, because these measures are resistant. So here is a summary which measures to report. When we talk about the shape of the distribution, if it's symmetric, the measure of central tendency we're going to use is the mean. The measure of dispersion is going to be the standard deviation. Now, if the shape of the distribution is skewed left or skewed right, the measure of central tendency is going to be the median, and the measure of dispersion is going to be the interquartile range. So, for the remainder of this course, the direction described the distribution will mean to describe its shape, skewed left, skewed right, or symmetric, its center mean or median, and its spread, standard deviation, or interquartile range.